Hello, Applied Science. This is a video I'm taking of something in hindsight I wished I would have done on when I moved this here concrete pad, because it ties in torque, it ties in our section on friction and coefficients of friction. So anyway, it was just an afterthought. I moved this pad from here over to here. We're going to put our barbecue there, and we're actually expanding, putting a 3-season porch here. But the point for this was how I moved this myself. We just barely moved that little one over there that we're going to go to in a second. But the way I did that, I'm just going to do it with a smaller piece, but then kind of keep this in mind, how you can move something using torque. Okay, we're going to talk about levers and leverage. So the first thing with that is it was sitting on clay. So the coefficient of friction of loose clay to that bumpy concrete underneath, the clay would have been really, so the friction of trying to move that, slide that, would have been quite high. So I put two 2x4s under, much like skis on a snowmobile. So that's the concept there. This piece, I'm not moving the 2x4s, I'm moving the concrete. Okay, this is where I said in the video, in the presentation on the Screencastify, where I said you guys are to make a lever with a fulcrum in the middle and show the mass on each end equal, and then change your fulcrum and see how much more weight you have to put on one end than the other, and then change the weight and play around with the fulcrum. So kind of playing around. But what I did say is your fulcrum can be at the very end. So right now in this situation, my fulcrum's at the very end, and my mechanical leverage, my load, is right there. If I put it under about 6 or 8 or 12 inches, and then there is my, right from here, the fulcrum is here, remember, my leverage is this whole length of pipe, but the load is from here to here. Okay, so it's a different mechanical advantage, but it works out the same as if you did it on the center. So basically, that was a heavy lift. This is not going to be, hopefully, too bad. We're into a little bit more solid ground. So basically, I just pushed that and was able to move the pad along. Now, the 2x4s the other day didn't move with it. It was that, and this is probably 1/4 the size of the other one. Okay. Now, I'm not strong. That's not what I'm doing here for this video. I'm just showing you how leverage can be used to move something a lot easier. You'll see the holes I'm digging as that fulcrum point is really hurt. But I'm doing that really with one hand. Okay. Now, if I had to try and drag that and push that manually, I can't. Okay. I can't. So that's the point with that one. I knew I couldn't flip that one because I knew it would break. This one I can flip, but it would still have the possibility that it could break if it was sitting on 2x4s. So I hope that kind of helps in understanding torque. Now, I didn't talk about torque here really. I'm just using leverage, but really it's torque. I've got a pivot point and I'm turning this. I'm turning, it makes a circle. I'm not going that far with my circle. I'm only going to about 80 degrees or so till that stops moving. But again, I'm using that half circle to get torque, which is a twisting force. So the twisting force, there's my force going up, okay, in a rotating motion. And there's my distance. So force here times my distance, the fulcrum's at the very bottom, and there's my torque. Now, if I had a lever or I could measure the pipe no problem, but if I had a scale here, something that told me how much force I was applying, I'd know how much torque it would take to move that piece of concrete. Okay.